Today's lesson is on rate of change and slope. The slope of a line in geometry is the measure of how steep a straight line is. The slope represents the rate of change and is written as a fraction in simplest form. The slope is the vertical change over the horizontal change and is represented by the letter m. The slope of a line can be determined from a table. You can either take the units from the table and count on a coordinate plane, or you can do it by subtracting coordinates using a formula. So let's take a look at those two methods. The first one we're going to do is we're going to find the slope by actually counting on the coordinate plane. So to do this, you need to, 1, find any 2 points that lie on your line, count the change in the y value, which is also known as the rise. That means we're going up or down. Count the change in the x value, known as the run, moving left or right, and write as a fraction in simplest form. So down here you can see that this is basically what represents the slope. Now we use letter m to actually represent slope, so we don't have to write it out each time. So the rise means you are going either up or down on the coordinate plane, and that is your y value. The x value is movement left or right. So here's some lines that I have already plotted on this coordinate plane, and you can also see the points here. Because remember, we need at least 2 points that lie on this line to actually find the slope. And they could be any 2 points on this line, but I've already selected them, so let's go ahead and do these. So we're going to do 3 different lines here, and we're going to calculate the slope. Okay, so this is going to be line number 1 right here. Now when you find the slope, you want to start at 1 point. I'm going to start with this one because I always like to find the rise first. So that means I'm either going to go up or I'm going to go down towards the other point. Since the other point lies over here, I'm going to move up. Now we make our movements so that they're at a 90-degree angle always. So I'm going to move up, so you're going to see me going up like this towards that point. So as I do that, I'm going to count the number of units that I move. So when I move from here to here, that's 1 unit, 2 units, and 3 units. And since I'm moving up towards positive numbers, that is going to be a positive rise. Once I get here, I have to move over to the right. So when I move over to the right towards this point, I'm moving over 1, 2 units. Do you see what I mean when I say we move at a 90-degree angle here? So this movement right here, it forms a 90-degree angle. Since I moved up 3, my rise is going to be a 3, and my run is going to be a 2. So the slope for this first line here is 3/2. So I'm just going to keep track down here of our slope of our lines. So the first one is going to be 3/2. I also know, since it moves in this direction, that it should be a positive number, and it is. Let's try the second line. I'm going to call this one my second line. So you can see the 2 points I already have designated. So with this one, I can start from down here, and I'm going to move up to here. So when I do that, I'm going to count the units. So as I'm moving here, I guess I'll put the dashed lines in here first so you can see where I'm moving. I'm going up 1, 2, 3, 4, 5, 6 units. So from this point to here is 6 units. And again, since I'm moving up, that's going to be reported as a positive number. Once I'm here though, I need to move left. When I move left on the coordinate plane, I'm moving towards negative numbers. So from here to here is going to be 2 units, but it is going to be negative. So my rise for the second line is going to be a positive 6. while the run is going to be a -2. Now, if you're still wondering why this is a -2, remember when we move left or right, that is this axis right here. And you know that these are positive numbers, yet when I move left, these are negative numbers. So that's why this movement left is -2. Now for this one, I can actually simplify this fraction into lower terms because I can divide both the numerator and denominator by 2. So 6 divided by 2 is a 3, and 2 divided by -2 is a -1. So my final answer then is just going to be a -3. So keep in mind when we have a positive number divided by a negative number, that is a negative answer. So number 2 is -3. For the third line, I guess I'll move over here to record my data. I'm going to start at this point and I'm going to move up. And it looks like that's 2 units right there. And then when I move over to the right, I'm moving towards positive numbers. So that's 1, 2, 3, 4 units there. It's really important that you remember which one your rise is. That's why I always like to do that first. So my rise was 2, my run was 4. And again, I can reduce this fraction. 2 divided by 2 is 1, and 4 divided by 2 is 2. So the slope of my third line is 1/2. Let's move on to the next slide where we have another way of calculating slope. We can do this by subtracting, and we use what is called the slope formula. So down here you see the slope formula. Again, m represents slope, and then we have a y2 subtract y1 divided by x2 subtract x1. So in order to find the slope using the slope formula, again, you have to have 2 points on the line. We're going to label the points and subtract, and then write our fraction in simplest form. Now when we use this method, the slope formula, we do not need the coordinate plane at all. We just need the 2 points. So here you can see the 2 points that are listed as they're ordered pairs. We know that x and y, x and y. And since I have 2 of them, that's why we use these labels. So I'm going to go ahead, and you should always label these first. So this is my first x, so I'm going to call that x1. This is my first y, so I will call that y1. Then these over here must be our x2 and our y2. Now remember, in our previous lesson on graphing, x always comes before y. That's how you should never get these confused. The first one is always the x value. The second number is always the y value. The next part is actually so easy because you're just replacing them in the formula. So in the formula, you can see I have y2 subtract y1. That is the difference in the movement of the y value. So my y2 value is a 4. I'm going to subtract that from my y1 value, which happens to be a -2. So that's 4 subtract -2. In the denominator, we're going to take an x2 value, which also is a 4, and we are going to subtract my x1 value, which happens to be a 3. Okay, so when we take 4 subtract -2, that is actually a 6. 4 minus 3 is a 1. Now, if this is a little bit confusing because you're still working on your addition of integers, you can even use a calculator if you want. 4 subtract -2, it's definitely a 6. Okay, I'm going to simplify this one more time because when the denominator is a 1, we can always ignore that. So it looks like our slope is a 6. If I reported it as 6/1, that's still correct, but I like to simplify until I can't any further, so 6 would be a better answer. Let's do the next one. Let's label them first. This is my x1 value, my y1, x2, and y2. Now all we have to do is replace them into the formula. Remember, m is standing for slope. We're going to start with my y2, which is a -1, subtract 0, my y1. My x2 is a -8, and I'm going to subtract my x1, which is a 6. From there, I'm going to go ahead and do my subtraction. -1 subtract 0 is still -1. -8 subtract 6 is a -14. A negative divided by a negative is always a positive, so that's just becomes 1/14, and we're done. Okay, so now we can kind of put these things together and go ahead and learn how to graph some of these lines. So in this first one, it says plot a line that starts at the origin and has a slope of -1 over, or -3 over 1, and we are to label it A. From our previous lesson, we learned that the origin is right here. So when it said we need to start there, I'm going to go ahead and make that our first point. To find a second point on the line, I'm going to use the slope. So since the slope is -3 over 1, -3 is my y value or my rise. The 1 is the x value or the run. So that means from here to go to -3 units, I'm going to move down 1, 2, and 3. For the run, it's a +1, so I'm going to move to the right 1 unit. And then I'm going to go ahead and draw the line as best I can. I know you guys can use a ruler on your paper, but I'm just going to have to freehand that, and there we go. That is line A. Now, what we had done previously is we already had the line, so if I want to go ahead and check this, I actually can. I can start from here and move up 1, 2, 3, and to the left 1, which is that -3 over 1. You're going to notice the more you do this, you'll figure out you can either form your 90-degree angle this way and then move left, or you could start from here and find your run first, and then you can find your rise. So you will notice that you can go either direction, forming that 90-degree angle, and either one is fine. Okay, so let me go ahead and do the second one. We are to plot a line that starts at 0, +4, 1, 2, 3, 4, which is right here. And we have a line that has a slope of -3/4. So this negative sign, you should always make sure you're using that with the numerator. So from here, I'm going to come down 1, 2, and 3, and then I'm going to move to the right 4. 1, 2, 3, 4. And then I'm going to connect those points. Oops, I did it the best I could there. So there's our second line labeled B. Now let me talk about this negative sign, for instance. If you want to write -3/4 like this, you can, and it means the same thing. I always tend to push this negative sign up in the numerator because you want to only use it one time. We can't, again, use it down here because that would change our answer. So here's a little reminder here. Make sure up and right are always positive movements. Down and left are always negative movements. On this last slide, there are a bunch of problems for you to actually try and graph these. So I'm going to do a couple of them, but I'm not going to do all of them just because it's going to make a lot of lines here on my graph. So I'm going to do the first one, and then I think I'll do the last two. So with the first one, it says plot the 2 points and find the slope. So I'm first going to start at the origin. I'm going to plot 1, 1. So I go over 1 and up 1. There's my first point. The second coordinate is -2, -1. So I start at the origin, move to -2, and then down to -1. So here's my first line right here. Kind of sloppy. But you can find the slope simply by counting now because you have your 2 points. So I'm going to go up 2 and over 1, 2, 3. So when I went up 2 units right here, because I'm going up, that is my rise. When I go over to the right, that is my run. So make sure when you write down your slope that you have a rise of 2 and a run of 3. You will notice that they are both positive because each time I moved towards positive numbers. I also know that because any line that moves from the lower left to the upper right is always going to have a positive slope. Okay, so let's go ahead and do, well, we should probably do a negative slope. So let's do the second one too. I'm going to do -3, +2. So I'm going to move over 1, 2, 3, and up 2 units. There's my first point, -3, 2. And then I'm going to go back to the origin and find where 2, -2 is. So I'm going over 2 and down 2. So this line moves in completely the opposite direction. It starts up here in the upper left, and then it moves down here to the lower right. Just going to try to make that a little bit better. It's very hard to do without a ruler. So now see how this moves downward? I know it's a negative sloping line, so I already know that this is going to be a negative number. But to do it by counting, I'm going to go down 1, 2, 3, 4, and over to the right, 1, 2, 3, 4, and 5. So this is -4/5. Remember, I came down 4 units, that's why that's a -4, and my 5 is positive because when I move to the right, that is a positive number. So this slope is -4/5. So I'll let you practice this third one, and then I'm going to talk about number 4 and 5. They are special cases, number 4 and 5, because what we're going to find with this first one is that it actually forms a vertical line. And this will form a horizontal line. The reason why I say these are special is because all vertical lines are going to have what we call an undefined slope automatically. And number 5, all horizontal lines have a 0 slope. So if you go ahead and graph these, if I go to -1, 0, I'm just going to erase this line here so that I can graph that. I'll erase this one too, so that we can see what these are going to look like. So with number 4, I'm going to go to -1, 0, that would be right there, and -1, -1 is right here. So you can see this is a vertical line. All vertical lines we determine have an undefined slope. For the other one, if I go to -3, +2, that would be there, and 2, 2 would be here, making a horizontal line. So in these cases, what I want you to remember is that all vertical lines always have an undefined slope, while horizontal lines have a 0 slope. So you can see that this has totally no slope at all, and it's completely flat. And down here, it kind of reminds you about those two things. Thank you for watching the video.